This week, my coworkers Wes and Chase join me to discuss how to protect AI data centers and BMCs, that soft underbelly of your IT infrastructure. Stay tuned. Below the Surface, coming up next. Welcome to Below the Surface. It's episode number 52, being recorded on Wednesday, June 18th, 2025. I'm, of course, Paul Asadorian, joined by Chase Snyder. Chase, welcome.
Hey, guys.
And Wes, you've decided to hang out with us. I thank you for that. You're always welcome. Wes Daubry is here with us. Wes, welcome.
Thank you. Joining you from Florida today.
Nice. And a fabulous wine collection in the back, I might add. You're making me want to have a glass of wine.
That's just the day drinking collection, my friend.
That's I see. There's a whole other cellar somewhere. I'll have to get a tour sometime.
What's the danger men drinking sign?
Yes. Just a quick announcement. Before we get into it, Below the Surface listeners can learn more about Eclipsium by visiting eclipsium.com/go. You'll find stuff there, like the ultimate guide to supply chain security, an on-demand webinar I presented called Unraveling Digital Supply Chain Threats and Risk, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. You can, of course, see our product in action by signing up for a demo. All that at eclipsium.com/go. Sorry, I'm losing my voice today. I don't know why. Maybe I was yelling. Went on the boat yesterday. Maybe I was yelling or something. I don't know.
That'll probably do it.
Yes. So let's talk about the AI infrastructure security. I think in a previous episode, I had Josh Marpet on talking about, I'm like, why is AI infrastructure a thing? So maybe we could just kind of recap that for our audience.
Yeah. So, I mean, let's think about the way that computing is going in general is, I always find computing to be a very cyclical process where things move, from a core, monolithic kind of architecture out to edge and then generally comes back. Mm-hmm. And a lot of that generally follows things like technical adoption curves where new infrastructure becomes incredibly expensive. And so then only certain players with that large capital can actually do those large infrastructure purchases. So to go and stay at that bleeding razor's edge, it's generally limited to some of the very few capital flush organizations on the planet that are specialized today. So what we've seen is as AI, quote unquote AI, has started to become to the forefront, the purpose-built data centers bringing in AI infrastructure have started to centralize into some, neo clouds and specific organizations designed for that. Now, what that has resulted in is that this kind of technology, while it's flowing out to the market, it still tends to be a little bit expensive, still tends to be specialized, which has ultimately resulted in organizations asking the question of, do we have the capabilities, specialization, and, interest in doing this at scale for ourselves? So that's ultimately resulted in a lot of these organizations continuing to steamroll or snowball that kind of effect where these neo clouds and AI data center providers are growing very rapidly.
You said that so eloquently, Wes. I was just going to pitch it as you moved a bunch of stuff to the cloud, so you have room in your data center. And to do the AI workloads in the cloud is super expensive. So you're putting it back in those empty racks in the data center are now getting filled back up with some of your own infrastructure, right?
Mm-hmm. Yeah.
Much like the cloud providers initially did a really awesome job of selling, hey, you should move your stuff into the cloud.
Yeah.
Make it so much easier. I don't really know if they pitched it as being cheaper or not, but it was like the general, the cloud hyperscalers, who they are, did an awesome job of convincing people to move critical workloads into the cloud. And it's repeating itself with the AI data center stuff where it's it's genuinely complicated to build out AI infrastructure internally to do even just to buy the GPU clusters,
right,
and deploy them. It's kind of different. Super prioritizes performance. You're working with bare metal. It's complicated in the same way that running your own data center is complicated, except more so in various ways.
Right, but what I think forced it was the large cloud providers putting a hefty price tag to run these GPU workloads, because largely this stuff runs on GPUs, and they're specialized GPUs. Because I thought for a long time, like, oh, GPUs are GPUs, the same ones people use for gaming, right? No, specialized GPUs for AI workloads, but also you can get that in the cloud expensive. Amazon recently said, oh, we're slashing prices because I think they realized that their market share might be shrinking because they basically priced themselves out of the market. Then you've got what you termed neo clouds. So I'm kind of old school. I think of this as like Linode before it got bought by Akamai, DigitalOcean, which are, I mean, still massive cloud providers, but smaller than the large three, right?
Mhm.
Oh yeah.
Amazon, Microsoft, Google, which can give you some great, I think more specialized offerings in some cases. Would you put Heroku? Heroku's kind of a weird one. Well, they got bought by, a lot of them got bought, right? Heroku got bought by Oracle, I think. Was it Oracle? No, it was Salesforce bought Heroku.
Yep.
So
Yeah.
anyway,
Yeah.
I have like a somewhat historical perspective, although I am still, they don't sponsor the show, obviously, but I still use Linode as part of Akamai because I have some stuff out there that I didn't want to move, and they satisfy all the requirements, and it works great. And it's just, I'm not doing any AI workloads in there, so.
Yeah, and the whole AI workload conversation, I mean, this is really just a conversation about efficiency and converting power to tokens. That's what all of this
Yeah.
really comes down to. And one of the primary concerns and the reasons why you see these organizations looking at it and going, hey, do we buy versus build in this scenario? And part of that is simply put, when you look at it from the life cycle of something like a GPU. You said it yourself, Paul. It's very specialized equipment that they're using. It's not just the commodity GPUs for gaming. And that in itself is causing an adoption curve that's accelerated and ultimately a shortened life cycle of these. When I talk to the AI providers out there, most of the time they're saying, look, in a year from now, this is no longer going to be the efficient system to do this. Now,
Oh, interesting. So there's a huge turnover now because as the technology gets better, it's worth the investment to go to the newer technology. If I can put the same workload and get it done in half the time with the latest, hardware.
yeah, and we're actually going to start seeing kind of a bit of fracturing between training and inference as well. When
Yep.
we look at the training side, building the models and actually just hard compute in that, you're looking at completely different infrastructure than you would for inference. Now we have
Right.
out there like Groks and TPUs, for example, that are very good at the inference side. They can just churn out tokens like crazy. And
Wait, so hold on. Explain that to me. What a
Mhm.
TPU is and a token in this context, Wes.
Yeah. So this is where I'm going to get a little bit out of my AI expertise because I'm not an AI engineer.
Me
But
neither.
when we look at, I'll just summarize with tokens being thought process and output from it. And so, like when you go to ChatGPT, for example, and you say, what is define the color blue? Every word that it spits out is effectively a token.
Okay.
So increasing that performance of it gives you the opportunity to spit out more tokens concurrently within a set of infrastructure.
Hmm.
So, when you think of hardware that's available today versus hardware that was available a year ago, we may be talking on some of the larger models because all of this is heavily model dependent in how detailed that model is.
Hmm.
That you may end up in scenarios where one of them's running at 3 to 4 tokens per second, whereas if you're using the latest bleeding edge hardware that's, let's say, 10 times as expensive as that older stuff, you may only see 10 to 15 tokens per second.
Hmm.
Now, I mean, all of these are abstracted numbers. Obviously, this could be widely varying dependent upon the infrastructure and architecture and models. But the core of this is that you are effectively using this hardware to take power, generate that output, and generate heat. And
Hmm.
and when we talk about data centers, like that's the core thing. That's why we're seeing them pop up in locations like North Dakota and Wyoming, and I think you're going to see Canada become an AI hotbed in the next couple of
Hmm.
years with hydropower. Of course, we have to talk about the Middle East and what Saudi's doing with their huge data center project too. But again, you're also seeing that you're going to have data centers that are focused on that model generation and training, and you're going to see data centers focused on service delivery or inference as well.
Right, right. And it's more costly compute wise to train the model than it is when you're running the inference aspect of it.
Absolutely, yeah, and that's the thing is that the hardware to do the training generally requires things like more memory, so that it can go and do, larger and larger model sets and training for that model sets, and then paring down or customizing and specializing those models. So that's where you're seeing things like NVIDIA's GB200s coming into play for doing these huge scalable data sets, or the open compute style architectures that Facebook and Meta is using for doing their model training, where we're talking about slamming as many GPUs of high performance as possible to do the most novel or niche training possible. And
Right.
that's really driving a lot of what's happening at the upper 0.1% echelon.
Right. But it's trickling down as organizations now realize that training a local model to help solve a problem in your organization is now achievable.
Mhm.
And you probably want to do it on your own hardware, as we established before. And so that's driving the need for people to now build out local data centers, train their own models. They're not the Facebooks, Googles, Apples of the world. They're in finance or whatever other industry. And they're like, oh, I mean, we've got use cases we've come up with, right? It'd be great to have a model that did this one specific thing for us. And if we could train it to do that, wow, we'd save like so much in maybe development time, or just have much better analytics in certain aspects. And it helps progress that in innovation even further. But we need hardware, and being a hardware, firmware, supply chain security company, that is where we come into play. Like, oh, you're running more servers now. Those servers have firmware inside of them. They have a lot of them are the NVIDIA line that I looked at was largely ARM Ampere
Mhm.
line CPUs, and the GPUs are most popular ones are Blackwell, is what NVIDIA calls the ones that are specifically used or tuned for AI based workloads, not to run whatever your favorite video game is. Now, there's anything wrong with that, and that's perfectly fine. But
Yeah, and that's absolutely it. I mean, and as we look at that move from Grace Hopper or the GH line of GPUs for NVIDIA, and they're moving towards those Blackwells. That's the whole thing is we're seeing customers that have literally bought hundreds or thousands of these things, as many as they can get their hands on, because of course there's supply chain challenges related to quantities. But then they're already saying, okay, we've implemented the Grace Hopper. We have 6 months to a year of life left in those before we've already started racking and stacking Blackwells.
yep.
Now, again, this is heavily driven by the business initiatives, and in some cases, if they're doing it for internal stuff, they're still leaning towards building workstations and smaller servers that are customized for it. Using things like the Supermicro GPU servers to put in 16 GPUs in there, and they're trying to do that as economical as possible to get as much power into it as possible. I'm also seeing things like people using as simple things like Mac Studios to do some, not necessarily training, but at least the inference for their own use. So in situations where you need your private model running so that you can do things in an offline capacity, things like that work great for it.
I'm also thinking make great password cracking rigs too.
That is
Okay.
very true.
Speaking
Yeah,
of that kind of a situation, though, like look, so GPU is really great for crypto mining, right? And I'm imagining a future scenario in which basically like the price competition for an hour of GPU time in one of these data centers is pretty fierce. There's this Silicon Data launched a Bloomberg ticker for the cost of an hour of GPU time. I think it's based on the H100, but it's like if a hacker broke into a data center, one of these AI data centers somehow, and just sort of carved off a little bit of the capacity to do some crypto mining, which this has happened at the, I feel like there was a huge time period where a bunch of people were trying to, were like, their personal computer was getting roped into a Monero mining botnet, and,
That
it
was the thing
uses
for a while. Yeah.
capacity. If that happened, Wes, you're talking about these organizations having like 6 months to a year to squeeze profit out of these GPU servers that they have deployed before those are essentially obsolete, and everybody wants the new edition. So the possibility, like the impact that a security incident could have on an AI data center, um, via impacting the performance. It's like I feel like we've talked a lot about historically, not yet on this podcast, but we'll get there. But the security impact of like losing data or model poisoning or critical private intellectual property getting lost by a data center getting hacked. But if you exact like a 1 or 2% performance hit on a whole AI data center because you break in there and start mining Monero with their GB200s, that could nuke the whole thing. That could tank the whole data center because they're
Right.
operating the price competition per hour of GPU capacity is so competitive right now, because of all these neo clouds are popping up, and of course the hyperscalers are doing their own thing too. I don't know, just thinking about
But
like
it's
the
interesting case to
priorities of
think
these
about.
things. Yeah.
Think about threat actors going after some of this infrastructure because of the high compute capacity.
Mm-hmm.
I tell a story a lot on the podcast, but uh, when I was at the university, someone there was a story. I wasn't there when it happened, but previous to me being there, and let's see, I started in 2001, 2000, something like that, and before that, someone had broken into a Cray supercomputer, and the only reason they knew someone broke in is because they patched the supercomputer to close out the flaws that they had used to get in to maintain their access. Now that same supercomputer today, my phone is probably faster than the correct supercomputer, right? But it could be a target for threat actors just based on the computing capabilities.
Mm-hmm.
Yeah, well-known attacker goal is to just steal capacity. It's not like the number
Well,
one
it's
thing,
almost
but the
like
crypto
bragging
mining use
rights,
case
right?
is real.
I feel like there was a time where there was bragging rights for like who could break into the fastest computer. I feel like that was the person who broke in the crate. Probably what they were trying to do is just maintain a foothold so they could brag to their friends.
Mm-hmm. Oh, absolutely, absolutely. The other aspect of things, Chase, you were talking about that impact to performance if an attacker was just using the capacity. One of the I just recently bought a new server at my house that I'm doing some GPU playing around with, and one of the things I found was for me to actually unlock all the functionality in the GPU that I purchased, I actually have to use third-party firmware on it, and
Mm-hmm.
it's like they took NVIDIA's firmware and then someone out there has modified it to unlock additional features, so that it can actually use its full capacity. I'm like, that drives me crazy for one, but two. Now I have to go out and download a firmware from a less than, you know, good site probably, and then throw it on my piece of hardware. And in that case, that gives me question about anything that would ever run on that GPU after that.
Absolutely. Well, I think a lot of folks don't necessarily focus on or even know that these GPUs run multiple different types of firmware for multiple different subsystems on the GPU. I mean, it's essentially a computer inside your computer.
Mhm.
I mean, other than the people who took they make like custom PCs, this company that I can't remember the name of, but they took a little Intel NUC and they put it on the GPU and like made a computer inside your computer. But that aside, even just these cards today, I mean, if you've ever installed a huge graphics card before, do you know that it's like tons of power cables going to it, and you need the little support brace, right? Because if it's sitting, I don't know if you call it vertical or horizontal, right? But like gravity, if your case has it sitting on its side, it's so heavy it would like snap the PCI connection, so PCIe connection. So there's like a little stand you have to put in there to hold them up. So these are crazy, and they have multiple. Our product does some enumeration of this firmware, which is how I was like, oh, and I think I've read articles in the past too that like there's certain subsystems that use this for a chip that uses this firmware, chip that uses that firmware. Because again, like your motherboard, tons of chips, tons of different firmware. Your GPU is basically just a multiplier now on top of that. And like you said, was getting that from a trusted source is really important because if your workloads are running on GPUs and the firmware has been compromised, figuring that out first is hard, and secondly, they're going to be able to persist for a long time. It's all the same things that we see in other types of firmware.
Mhm. Yeah, and when you look at that, NVIDIA, I'll use as an example. NVIDIA actually can allow you to do measurements and attestation of GPU and the code running on it, as well as verification of that versus the driver within the operating system or kernel.
Right. Yeah, because the driver is different. I think some people may get those confused. They are both low level, right? But the driver is the one on Linux that usually causes problems, although much better lately. And there are open source efforts for that too, which is interesting.
Yeah, so it's actually quite amazing that to your point, they built a framework where it's ultimately very similar to what we're used to on x86 type of devices with things like Secure Boot and similar, where you actually want to be monitoring the integrity of the firmware and the driver, and even now getting into a full chain of integrity or chain of trust, where you're now building upon that, where you're verifying that the firmware on the card, the BIOS on the graphics card is appropriate and matches what you're expecting, as well as that your driver matches with that, and then the code that you're running from a kernel perspective matches, and then your container system, whether you're using container IO or whatever, matches, and you're now building these layers upon layers to actually validate the integrity that when you are doing, whether providing service through inference or training, you actually can trust everything bottom to top.
This feels like a good moment to segue into the potential challenges involved when an AI data center, one of the big neo clouds, is renting out capacity to their customers, big enterprises that decided they're going to use the cloud, they're not going to build in-house, or just for some use cases maybe. And because of the performance demands, the customer needs bare metal. And so they're getting pretty deep access to the hardware inside of the AI data center, and they can do, there are probably contractual requirements about what they're allowed to do on it, but fundamentally they can do kind of whatever they want on there. And then you, the NeoCloud, AI provider, are going to take that back when they're done with it and rent it out to someone else. What can happen? Put on your black hat right now, and if you're a nefarious actor and you want to rent out some capacity from an AI data center, bare metal style, what would you do if you were trying to introduce risk? What are the vectors there?
Yeah.
Well, it's a nice attack because it carries over to multiple customers. So I just got to get some code running on one GPU, and every time that gets recycled to a new customer, now potentially I have access to their data.
Mm-hmm. Yeah, I mean, there's absolutely that attack vector, and you kind of hit the nail on the head there when talking about things like bare metal systems. When someone's provisioning a bare metal system, to get the highest level of performance out of it, you're basically giving access directly to hardware APIs. Yep. When you get that level of access, anything that you could do around things like updating of firmware or settings on that thing is also acceptable for not only read but write in most of those cases. So, if I were an AI attacker researcher, for example, first thing I would try to do is embed myself either in the host operating system or in the GPU, as Paul mentioned there. The other thing I would do, and largely one of the first things I would do, is try to see if I could query other potential attack vectors, like looking for BMCs. So if I have an IPMI driver that's available to me, first thing I'm going to do is look at that and see if I can get any data out of the host system's infrastructure itself. Now, if I do manage to get, there's multitude of different things like authentication bypasses and privilege escalations for things like ILOs and iDRACs, for example. If I get into that BMC, now I can implant in there. Now I not only own the physical hardware, I can get anything out of the operating system, anything out of the hardware. I can also go and use that to move laterally within a management segment to other hosts within a data center too.
And that's super dangerous. It's always been that way since we've had BMCs. Is what if you put all your BMC on your management network, it only takes one, and then they can gain access to all of it. I remember years ago having conversations with a security researcher who did security research on BMCs years ago, saying the exact same thing. And I think if we sit here today, those attack vectors 100% still exist because we are actually publishing a paper today where we worked in conjunction with AMI to analyze some of this space as well. And I mean, the long story short in the paper, now, again, we did this in partnership with AMI, so I'm biased in saying this, but gaining insights as to how AMI is managing their BMC code, they're doing an amazing job, right? And then you look at how other people are doing it, it's just not as good, right? Because they're basing it largely off open BMC. They're implementing their own APIs and code based on the Redfish specification, which, if you look at our previous research we've published as Eclipsium, has 3 different rounds of vulnerabilities that primarily our researcher Vlad, who's been on the show before, has spearheaded. So this is a ripe attack surface. I was talking to because he's coming on my other podcast, HD Moore was talking about how BMCs. He's like, dude, there's a ton of BMC stuff out there, and like we're working really hard at Run Zero to be able to enumerate as much of that as possible. Of course, we have our own software that does a deep analysis. Run Zero is focused on the discovery. Our platform is like deep analysis, and there's a lot of attack surface there, and a lot of it is very vulnerable. But it's frustrating too because it's a fixable problem. But now coming back to the AI data center, once I'm on the BMC management plane, now I have access to, as you said, Wes, I have access to everything as an attacker. I mean, the highest level of privilege in the lowest, deepest portions of the hardware, that's where the BMC gets you.
You got
There's extremely real precedent for this too. Before I worked at Eclipsium, back in 2019, the research team here discovered this attack vector they named Cloudborne, which is this exact scenario. It's that bare metal cloud infrastructure is getting leased out. They describe it as a problem with the reclamation process where the firmware was not reflashed between customers. So the cloud provider reclaims it, doesn't reflash the firmware on it. And in that Cloudborne scenario, it was a vulnerability in supermicro BMCs, or a vulnerability in a supermicro hardware that was used to overwrite the firmware of the baseboard management controller that allowed the adversary to then implant a backdoor. So that was a real one that happened in 2019. So that's that's kind of before the major neo cloud AI data center situation started really taking off. But there are absolutely BMCs in the AI data
I described
centers,
it when
and
I was on
this attack surface is still there.
I was on another podcast. I forget which one. It might have been Security Cocktail Hour or something like that. But I was like, look, BMC is at a high level is very simple. Like, you like computers so much, I put a computer inside your computer. Your BMC is typically an ARM-based computer that runs Linux inside of your computer. Like, you can run whatever operating system you want, but know that there is a Linux server basically inside of your computer. And
100%.
Linux on ARM is a ripe attack surface. There is, it is, another Linux box. Basically, it just runs ARM. It's a very popular platform to run Linux on. Tons of malware is compatible with it, and they typically live off the land. The whole thing. And those chips are typically made by ASPEED. There's different versions, but they're essentially ARM-based Linux computers.
Yeah, I'm looking at the NVIDIA docs page right now, and it says NVIDIA BMC is based on the OpenBMC open software framework, which builds a
That's good.
complete Linux
I was going to
image
ask.
for a board management controller.
Yeah,
You got a whole
and
Linux.
look,
Yeah,
and OpenBMC isn't bad, right? So I'll give you some insights in the paper that we analyzed a bunch of this code. OpenBMC is great, by the way. They use a Yocto build system, and they do a good job of trying to keep their base images up to date. And the build system is actually great. Like, I used it, I built an image, it worked. It didn't scan horrible, but you can customize that however you like, right? And so The moment you got to bring in a proprietary component, now you're stuck on a certain Linux kernel version, and that software starts getting crusty. So it depends on how well maintained your OpenBMC. I'm not sure how. I don't think we evaluated NVIDIA's OpenBMC implementation, but it can also vary from hardware platform to hardware platform, right? So the older hardware platform has this version of BMC that basically is a fork and went in one direction, and then the latest one is maybe a newer version, but now you've got like basically two completely different Linux distros with different sets of problems of trying to backport fixes and things like that. Excuse me.
Yeah. So I'm gonna ask a question or actually point out something here. It's like even when you use something like OpenBMC, and this is I'm gonna get on my soapbox about transparency here. And when we look at all the BMCs out there, whether you're using the super micro BMCs, ILOs, iDRACs, or others, none of them give a capability to do an attestation on that device or provide any sort of a reference integrity manifest, or even using some of the newer technologies like SPDM, where I need to be able to go and verify that that BMC is what it says it is. And there's no real technologies to do that. Now, on some of the older A-Speed stuff, A-Speed based things that you were mentioning before, there was actually a way of extracting it so that you do independent integrity verification on it. But nowadays, they've all built it so that it's kind of a one-way API. You can write a BMC update through the BMC APIs, but you can't verify it in any way, shape, or form. So if I go and take a BMC and I happen to go and grab a copy of OpenBMC and I kind of modify it slightly to have some kind of an implant in it and throw it on a device in a data center where they may not be as mature as others, do you think they're going to notice that I've now put a compromised OpenBMC image inside of their environment? Well, they don't have to do it.
So many places I want to go from here, Wes, because what you reminded me of, I believe, and I'm not picking on Supermicro, but they had a vulnerability and they fixed it, and there might have been even more than one that allowed an attacker to bypass the signature verification of the image on the BMC. Look, Supermicro is not alone. I'm just saying that was one that I recognized recently, which is super interesting in the context of what you were describing, right? Because if I do have or find one of those vulnerabilities, that means what Wes said, I can put my own customized backdoored firmware inside of your server, basically, which is pretty awesome. Also, it is super frustrating, and I've worked here 3 years now, and this frustration has continued every time we talk about it. With what you were saying, Wes, that it's so when we look at a spy flash as an example that holds UEFI, in most cases we can take an image through software of your spy flash. And basically, if you're familiar with the Linux command dd, essentially a dd copy of the storage that holds your firmware. In the case of BMCs, the technology is designed and implemented such that we can't go to the spy flash chip that holds the BMC image, pull it off, and then analyze it. So when I say we analyze it for the AMI paper, we analyze the firmware, like just the firmware before it goes on the chip. There's differences, right? What's running on your BMC could be different from the image that was installed. So yeah, that is super frustrating.
Yeah, I mean, this I will always echo my call for transparency from the OEM ODMs is that in these scenarios, if they just gave me something as simple as a PCR or a hash of what that firmware is so that I could independently verify it and validate it and track it for change, that's all I care about.
Right. That would be great.
Yeah.
And
now,
this is a topic that has been getting a little bit of attention in it's like NVIDIA is aware that this is a challenge, and they actually published this great article recently called "Analyzing Baseboard Management Controllers to Secure Data Center Infrastructure." So they're sort of plugging together, connecting the same dots that we are. That's like, oh, BMCs as an attack surface for these AI data centers, and I'm looking for the quote here where it says, okay, their offensive security research team analyzed BMC firmware used in data center environments, identified 18 vulnerabilities, and developed 9 working exploits. And they published they published a whole paper about this. So
it's an awesome paper. Also, I recognize the name Alex Tereshkin. Um, he has published numerous research articles and discovered vulnerabilities, and so much so that I recognize his name in this context of UEFI and BMCs. So they brought their A team to look at the BMCs, in my opinion, and they did a great job. This is a great report.
There's this there's a sort of whole global narrative that's happening where tons of new AI data centers are getting built. We talk about AI data center infrastructure in terms of the chips and the hardware and stuff, but it's also being treated as critical infrastructure in a more general sense, like electricity and chemicals manufacturing. It's like AI is getting used for defense applications and for power grid management, all kinds of stuff. It is critical infrastructure, and it's getting built at just a breakneck pace all over the world. I heard a quote recently from a think tank congressional testimony that was like, "This is the primary arena of competition for dominance in the 21st century. It's like the century of AI." And so when you're critical infrastructure like that, you have a target on your back. Obviously, the most sophisticated nation state APTs are increasingly incentivized to target these. We've already seen a huge swath of APT groups targeting telecommunications worldwide and using very sophisticated techniques and not so sophisticated techniques, and targeting the IT supply chain specifically, using software vulnerabilities and hardware supply chain vulnerabilities to get in and lay low and live off the land. And there's just every reason to believe that an AI data center that is being publicly discussed as being under rapid construction would be a target for that type of an attacker. Wes, I feel like I interrupted you a second ago. What?
Oh, I don't remember what I was going to say, but I mean, what you just said there, that was absolutely where it goes into the supply chain security aspect of things. Yeah. And that's twofold. One is I always consider things like software supply chain validating vulnerabilities and integrity and threat of software coming into my infrastructure. But the hardware supply chain is another critical piece of that. Especially in these scenarios where we're talking about these huge data center build outs with huge amounts of infrastructure coming into it, building a program to do the proper amounts of validation of that infrastructure. And I mean, that could be, I have some customers that go all the way to, having a pipeline that x-rays equipment as it comes in to verify against known good chip layouts, all the way to other ones that are going on top of that using our technology to validate firmware, and then others that are using things like, I mentioned SPDM before, and things like DICE, and they're building a CSCRM program or Cyber Supply Chain Risk Management programs using SBOMs of both software and HBOMs for hardware, and my favorite FBOMs for for firmware. But we're now at a point where, to your point, if organizations are not looking at every layer of the stack from every attack vector, that attack vector that they're not looking at will be the area that APTs concentrate on. And it's an all or nothing scenario. If you don't protect the perimeter, an attacker is going to find that hole in the Swiss cheese and come in. If you're not protecting your supply chain, well, that could be something like, they're dropping USB keys in the parking lot, to they're intercepting things from value-added resellers and strategic integrators to implement something in your organization.
It's interesting to think about the threat actors going, if only I could put like a small computer inside of all the servers so that I could maintain access. And if that little computer had access to all of the hardware, and it's like, oh, wait, that's already built in. And it has a legitimate use case for it. But also, if it falls into the wrong hands, then it's game over.
Yeah. And not only is it already built in, it has a driver to directly interface with the running operating system. It has hardware interfaces to communicate on SPI to the processor. And it also has direct memory access in most cases too, where it can directly exfil information if you're talented enough.
Right. Yeah, it's a crazy attack surface to think about.
Mm-hmm.
For sure.
And it's one that organizations can't currently validate against threat.
Yeah. So keeping it up to date and segmented is still difficult
Yeah.
because the attestation is missing. How do I know what's running on it is good? How do I know what I'm putting on it is good? I mean, maybe I can validate if I'm going to put some firmware on it if it hasn't been backdoored because I have that. But if it's a capsule like in UEFI, you're not getting the full firmware. You're just getting the updates to put on it. So I can't. I mean, I can validate the updates, but that's only part of the thing that I need to validate, right? So those things are interesting to secure. And you see the advice that has like, oh, well, don't expose them to the internet. Like, okay, we got it. We're not going to expose it to the internet. However, we still need to work really super hard to lock these things down. And I feel like this is something that doesn't get enough attention.
Mm-hmm. Yeah, and I mean to talk about the segmentation part, this isn't just segmenting into its own network segment. I mean, this is leveraging technologies like ZTA or zero trust architectures, or
100%.
going so far as things like PV lands to segregate one host from another host.
Yes.
And yeah, does it make our lives more difficult from a management perspective? Absolutely. But without having that super critical level of isolation of these hosts, we're never going to get to a point. We're always going to have that attack vector of lateral movement from management interfaces on these things. And that's been, something that when I've done security assessments for enterprises, one of the first things that I always do is, your devices with the most critical network interfaces, the management interfaces, are all able to talk to each other. And that is a key way that you can have lateral movement upon a device becoming compromised.
So if you guys were going to build out the attestation and the sort of security validation from supply chain, like from receiving hardware onwards for an AI data center or any sort of data center, high performance computing data center, any sort of a situation where you're onboarding hardware into a situation where it's going to handle sensitive data and you don't want it to be compromised, what are the sort of basic requirements that you would put in place?
Yep. Yeah. So the first one is I'll give you the solution that includes Eclipsium, and that's ultimately Eclipsium is going to help on the hardware validation, the firmware validation on most of the components in the system, and then also go and help in the runtime and operational monitoring of that device for change, risk, vulnerability, and those types of things. If I wasn't using Eclipsium, there are some, and I had a Linux-based architecture. That's a key part. Is most of this stuff these days is built upon open source and Linux. So you're seeing things like NVIDIA's released an attestation suite of products that validates the measurements and the reference integrity of the GPUs and the code running on them, as well as the driver to validate that layer. Below that layer, you're stuck with things like TPM-based measurements in most situations, unless, of course, you're doing your own hardware. In that situation, you can use things like IMA or Integrity Measurement Architecture, which is maintained by Linux or the Linux team, I'll just say. You can also use things like LCM, which is a Linux kernel integrity measurer, which allows you to validate that your kernel matches what you're expecting. And a lot of this now gets to a very high level of maintenance, because unless you are maintaining exactly what your kernel to be that you're rolling out, and not doing anything like DKIM or dynamic kernel modules, you've got a scenario where you're having to understand exactly every piece in your infrastructure. So while it may work on 5 servers, 10 servers, 100 servers, the level of scale suddenly makes this to be a relatively difficult process to manage. But then when you start getting on top of that, starting to look at things like the integrity of the software running in your stack too. And there's tools out there like, I'll just say things like NSA has released a tool called MAAT, M-A-A-T, which is their centralized software integrity solution for validating and attesting to software matching what you're expecting it to. But again, all of this comes into the building those layers of trust using industry standard capabilities to have one layer check the next and vice versa before everything is working.
It's interesting. I see articles that advocate for secure boot being enabled, and other ones from the Linux community that advocate for it being turned off. But you should listen to Wes, especially if you're building out AI infrastructure, and you should be at least trying to use all of the security controls that are offered on the platform. Uh, Oftentimes, you're going to run into cases where that feature isn't available or hasn't been configured properly. You might be able to configure it properly on your own, or you might not. In the case of like Intel's boot guard, you're kind of at the mercy of the OEM, whoever put that platform together. So they have to do a good job in enabling and configuring all the security controls for that platform. But just general advice when you're deploying new infrastructure, such as for AI, research what do I have available to me to do the attestation activities that Wes was mentioning, right? Whether that be secure boot, whether that be some other attestation, all the way down to your Linux kernel and kernel modules and drivers, right? You should definitely be doing that, because all of that is going to help you have a more resilient system. And then there's the management right end of it, locking down your management interfaces, monitoring your management interfaces, and things of that nature. I'm not sure. I think it varies per manufacturer in terms of authentication to your like BMCs, for example. How much flexibility, control, and features you have. Can you enable multi-factor authentication? How is the API secured, and the details of that? It varies per vendor, but those need to be discussed and have a proper implementation as well.
Yeah, and what you'll find there is many of them will leverage an external authentication mechanism. I typically see things like LDAP being leveraged.
Yep.
And if you can use LDAP, or in some situations OAuth, you move that MFA out to, or second factor, multi-factor authentication outside the BMC. The BMC itself is still going to be basic, and many of them will have hard-coded credentials. And those hard-coded credentials may, in most cases, be able to be derived from if you have access to the hardware. So that's one of my favorite things is, when you buy, I'll say like an HP server, for example, you get a little card on it that you pull out of the server and it gives you your ILO password on it.
Yeah.
So then if you don't change that password, and I'm an attacker and I have keys to the kingdom and I can pull all the static identifiers off the system, I'm pretty confident I could generate that password from that. And then from there, always have a persistent access mechanism with full admin on the BMC.
Mm-hmm.
A funny little side note about that is, as I was reading these NVIDIA docs about their their BMCs, their BMCs do have a default password for the root user that you're supposed to type once Linux boots, and it's 0PEN capital BMC, so open BMC but with a 0. It is set to expire upon first login, and then you have to set a new password, configure a new password with 13 characters, at least one uppercase, one lowercase, and one digit. So, they're doing password requirements. But yeah, default passwords are a thing, and not everybody is going to have that expire after first login sort of parameter built in.
It's interesting though, and correct me if I'm wrong here, but the BMCs that run Linux inside of your computers don't give you the capability to do forensics, incident response, or put an EDR software for monitoring on that Linux subsystem, much like VPN appliances, network and security appliances have that locked down environment where they do, many of them run Linux, but you don't have access to it. So it's super hard it's impossible, or next to impossible, I should say, to do any kind of monitoring. You don't get EDR, as we've said, on your network security appliance, but you don't get it on your BMC either, which that makes it a target-rich environment for threat actors. Oh, there's this open source Linux subsystem. Oh, wait, I know Linux as a threat actor. That, by the way, no one's able to monitor on their system, so that may be where they want to live, much like VPN and security appliances.
Mm-hmm. Yeah, I mean, you hit the nail on the head. His BMC architecture in general is a black box. We are getting to a point where we're getting some management interfaces to those, like SSH to a BMC, where you can then start doing some active real-time monitoring for IOCs or indicators of compromise on them, as well as we can get things like some high-level logging from them. So, simply put, having BMCs send audit logs or events and alerts out to centralized SOC solutions like SIMs is, base level of what needs to be accomplished to monitor for indicators of compromise, indicators of attack.
Hmm.
Now, I think we're going to see an expansion of the tool set capabilities, but to your point, is it something that's known and vetted from the manufacturers? Absolutely not. They don't want anything additional running on there. But I can tell you, I'm absolutely have a project where I'm looking at implantation into BMCs real time so that we can go and actively monitor on it. And I want to be able to actively monitor on those devices. So we might see more tools like that in the future.
Yeah, I do. Well, I think it's a good note as you are procuring equipment. The question is, does it provide me SSH access? I know that sounds like a very technical requirement, and it is. However, many security solutions, ours included, can have a great time if there's SSH access. That can give us a great level of visibility into whatever Linux device or component that you have in your systems or the system itself.
Yeah.
We're getting into the topic of device lifecycle management and procurement and stuff, which I'm curious for you two guys who I know have, shopped for gear at an enterprise scale before, how much say security gets in these various stages of the device lifecycle. Like at any given organization, is the security team or security expert or whoever, assuming it's a different person than the IT person, which is not always a safe assumption, getting consulted about asking those kinds of questions about like when you're bringing in new stuff, it's like, are we going to have SSH access to this, or what level of visibility is the security team getting consulted for? What level of security requirements should be in place, or access visibility monitoring attestation requirements should be in place before new IT stuff gets onboarded into the organization?
I hope more so than 20 years ago, although Wes, you probably have a better pulse reading on this.
Yeah, so it heavily depends upon the maturity of the organization. Some organizations, they think, hey, as long as you're buying from a trusted vendor, we really don't care about the hardware. As long as it meets their minimum controls, which in some organizations, that's as simple as you're running our enterprise managed operating system with our enterprise managed security tools on it. That is one of the key things, is that places just simply do not even think in a lot of cases about the hardware and the firmware built into that hardware from a security perspective. Now, that is an area that I am heavily pushing for organizations to change, where as part of that, the validation and capabilities to verify everything coming in from a supply chain perspective and then ongoing do verifications against it is going to become critical and paramount. And, some of our more, I don't want to call it mature, more bleeding edge customers are building strategies towards that, where even moving away from things like secure boot into situations like looking at measured boot, for example, where instead of having a root of trust that is managed by the OEM, for example, or by Microsoft, they're looking at managing it themselves so that they can be in control of that verification that things are what's expected. Now, a huge part of this, and this always goes back to this conversation when we talk about root of trust of devices, is some organizations are not comfortable with taking the operational risk of a device not booting because of some change. So they let the OEM manage it and trust the OEM. Now, I've done plenty of purchases over my career where I've said, yep, nobody gets fired for buying HP, IBM, Cisco, or any of those things because they're a trusted vendor. And I have limits of liability and I have insurance contracts written up to protect my organization against this stuff. Nowadays, I talk to customers that say, you know what? I don't care about any of those people because they're not doing the things that we need to do to validate the trust of it. So either I'm going to go build my own systems because then I can have full transparency to what goes into it, or I'm going to use things like, Open UEFI or whatever the Open UEFI framework is, the firmware for that, or things like Open BMC to apply my principles that I need on these devices.
Mm. For sure. Yeah, it's interesting. I hope that there are checks and balances for security in the procurement process. Oftentimes, I find that they're kind of like time based. So, if the security team does a 3-month evaluation, finds a couple things, like, well, you took 3 months to validate it. I've been in situations where, at the university specifically, we're looking at new, very important software, and I spent literally 15 minutes and I found, 16 cross-site scriptings, and managed to exploit one, and didn't take me much time. And I'm like, this is an indication that this is poorly maintained software. I think we need a similar process when we validate firmware, hardware, and all of that stuff. We have to put that first check on there. Our product is great, great check, has a lot of reputation stuff in there as well, and the ability to check things. If you can easily find some of these vulnerabilities, it may be an indication that it is not going to provide integrity for your platform, which is something to bring to the table, certainly at your company. Whether they listen or not, obviously it's going to differ per organization. But that checks and balances, those checks and balances, Chase, are extremely important.
Yeah, the what you just described of easily finding those vulnerabilities, we're seeing these trends play out where historically over the past several years credential abuse has been one of the major, like the
Hmm.
top initial intrusion vectors, because there's been tons of data breaches, lots of email addresses and passwords are out there, people are reusing them. Multi-factor authentication hadn't been widely adopted for a while, and so the easy way for an attacker to break in, get initial access to an organization, was to go buy credentials on the dark web and just log in. Attackers don't
Hmm.
break in, they log in, right? That, according to the Verizon data breach investigation report from this year, credential abuse is on the decline, and exploitation of vulnerabilities is catching up to it. They've almost met in the middle at this point. And specifically, exploitation of vulnerabilities on network edge devices,
Hmm.
VPN gateways especially, but routers, switches, firewalls, load balancers, all kinds of network gear is being targeted with these vulnerabilities. And it's because that's the low hanging fruit for attackers now.
Right.
Organizations have done a much better job of enforcing MFA or doing just the baseline protections. MFA isn't a cure all, but it's way better to have it than not.
Hmm.
And so they've done a lot better at removing that as a vector, or just introducing friction and imposing cost on that vector. But they're now discovering that these opaque network devices, including even firewalls and VPNs, which you install for their security benefits. You put in the firewall and the VPN because you think it'll protect you, and it turns out to be the door through
Yeah.
which the attacker enters the environment because of these vulnerabilities that, in many cases, because of how these appliances are, you don't have that visibility into where the vulnerability is. So that shift in attacker tactics towards exploiting vulnerabilities, particularly in network devices, and now in AI data center, AI sort of contexts, we see so much conversation about preventing the models from getting jailbroken, or like model poisoning, data poisoning during the training. We don't see a lot of discussion about the infrastructure level, the
Mm.
hardware and the firmware and the GPU level security, but that's going to be where the attackers target, because it's underattended to, excuse me, and it's just a lower priority. As they build out these AI data centers, the concerns are power, cooling, and GPUs. Being able to buy them, the constraint on the supply chain for the hardware itself, and then the ability to power it, because they take an incredible amount of power, and then cool it in order to keep it operational so that you can sell as many of those hours of utilization as possible. And security of that hardware and that infrastructure is not among those top priorities. But I think that once we see an AI data center get compromised through a BMC firmware vulnerability, there's going to be more attention paid to the security at that level.
Yeah.
Yeah, and I love what you just said, Chase, and it also reminds me of the NVIDIA paper that looked at the breaking BMCs. They mentioned the Microsoft data center that was deployed in the ocean underwater for some of the reasons you talked about, obviously cooling, right? Get plenty of seawater to help cool it. But you also don't have ready access to that data center, which I think is the point that they were making of why BMCs are important operationally. And now, if they're important operationally and they're kind of low hanging fruit security wise, if we've established, that is going to be where attackers go. So you're likely not going to see people go, I'm just going to turn off the BMC functionality altogether because they need it to manage their data centers. That's where attackers are going to gravitate to. So, yeah, make sure I'll put those links in the show notes for this episode. There is a paper being published that we did in conjunction with AMI that's amazing, and you should absolutely read it to gain some more insights into the BMC threat and vulnerability landscape. And recent blog posts on our support for AI data center infrastructure to help you secure that environment is on our blog. So, Chase and Wes, thank you for joining me today.
Happy to be here.
It's been a
Thank you,
delight.
everyone. Yeah, thank you, everyone, for listening and watching this edition of Below the Surface. That concludes this episode. We'll see you next time.